Example 2 describes a situation similar to what we did in example 1, except the velocity function is now 3x, and the velocity is measured in miles per hour, and x is measured in hours. And so again, they want us to find the area under the curve, and in this case, for part 1, it's between 0 and 6. This is actually a typo right here. It's not supposed to be a 3 because they said during the first 6 hours, so that should be a 6. So please make sure you fix that. So in any case, let's go ahead and make the graph. So again, we have an XY plane, and since time cannot be negative, the graph is gonna be a line that starts at the origin and goes to the right, basically. So this is the graph of v of x, which is equal to 3x, okay? So it starts at 0 because when x is 0, the y coordinate is automatically 0. When x is 1, the y is gonna be 3, and so on and so forth. Now, I care about 0 and 6, so at 0, I know that the point is gonna be 0, 0. Again, how am I getting these numbers? I know I'm starting at 0, and when I plug in 0 into the formula, I get 0 times 3, which is 0. So the velocity at time 0 is 0. Perfect. What about at time 6? How fast am I going there? Well, again, I plug in the 6 into the formula, and I get 18. So when time is 6, the y coordinate is going to be basically some sort of a number, and in this case, the number is 18. So that's the end right there, 6, 18. All right, so now that we have all this information, we need to figure out the area inside the region described or enclosed by the graph of the function, the x-axis, and 0 and 6. So basically, that area for me pretty much looks like a little triangle. And so if you remember, areas of triangles are basically base times height divided by 2. So hopefully you remember that. If you don't, no, well, now you do. So the area in this case is going to be 1/2 the base of the rectangle, or the triangle rather, times the height of the triangle. And let's see, on this graph, what's the base and what's the height? Now, for this problem, it looks like this side right here, the one connecting the one connecting 6 to the graph, is perpendicular to the x-axis. So that's going to represent the base or the height. It doesn't really matter, it's either one. So again, that's the base or the height. So that means this side over here is going to represent the base or the height also. So one of them should be chosen as base, the other one as height. Let's pick this one to be the base, and let's pick the other one to be the height. Or the other way around, doesn't really matter. So how much space is there from here to there? I'm starting at 0 and I'm ending at 6. So there are 6 steps. So that's the height. And what about the base? How big is it? Well, I'm starting from the x-axis where the y-coordinate is 0, and I'm ending at the point where the y-coordinate is 18. So to go from 0 to 18, I need 18 steps. So that's my base pretty much. So in this problem, the area is going to be 1/2 times the base times the height, which is basically 54, and the unit is miles. So the distance traveled in this case is 54 miles. So in part 2 of the problem, we're going to be looking at similar situation. We're looking at distance travel between the 3rd hour and the 5th hour. So we're going to make the graph all over again and determine what the numbers are going to be. So here's the xy plane again with the function v of x drawn, and we need to figure out what the graph looks like and what's the area under the graph. So here we go, we drew the graph, and now we're looking at the area. It looks kind of an odd shape. We call these shapes trapezoids. A trapezoid is a shape in mathematics where 2 sides are parallel and 2 sides are not parallel. For me, the ones that are parallel are the ones that I have in dots right here. Those are the we call them the small base and the large base. So this top one in this case would be the small base, and the large one is the large base. Okay. For me, this is the small base and this is the large base. And so the area of a trapezoid is a strange one. It's kind of like this. It's 1/2 times the height of the trapezoid multiplied by the small base added to the large base. And what's the height? The height is the distance connecting the 2 bases with one another. So this right here is the height. In my case, the height is the amount from 3 to 5. Okay, so we're gonna need to find all these numbers. So starting with the height, how much space is between 3 and 5? Well, to go from 3 to 5, it's 2 steps. or 5 minus 3 gives me basically the 2. So the height of this trapezoid is going to be 2. What about the small base? Well, in order to find out what the small base, I need to measure this dotted line. So all I have to do is figure out what the point is. And so remember, the point is 3 on the x-axis. And to get the y, I plug in 3 into the formula. 3 times 3 will be 9. So that's how much the small base is. It's actually 9 steps. For the large base, it's the second dotted line. And again, to find out what the numbers is, I'm going to go ahead and put 5 into the formula. So 5 times 3 will be basically 15. So the large base is going to be 15 in this problem. So now that we have all the numbers ready to go, let's plug them in. So the height of the trapezoid is going to be 2, and we're going to multiply it with the small base, which turned out to be 9, added to the large base, which turned out to be 15. So when we add and multiply and subtract and divide and everything else, we'll get the solution. And this solution will represent the distance traveled by the object. So the answer, I believe, is going to be 24 miles. Okay, and again, it's a smaller number than the one we had earlier because we spent less time driving in this case. We only spent 2 hours driving. That's the pink number. Whereas over here, we spent actually 6 hours driving, which was the base of that triangle. So again, regardless of what the shape is, the process is always the same. Come up with the formula, find the numbers to plug in the formula, and then get the answer.